I wasn't. So I'm gonna record it from now on. That's okay. The first part of the class was kind of boring from the point of view of a viewer. I'm sure you guys had fun. But I'll record the rest of it so you guys can go back over the solutions. Okay. So yeah, unfortunately, sort of it erased all the annotation, but the solution here was -1 and -5. Okay. Any questions with this? Okay. Let's look at number 2. So number 2 said, check that the point is a solution. So that means you're not graphing, you're not solving, you're trying to figure out whether these values work in both equations. Okay, so a solution to a system means that it has to work in both. So let's plug it into the first equation. So the first value is x, the second value is y. So I have 7 times 1 minus 4 times -2. So 7 plus 8 gives me 15, which is not equal to -1. All right, so this did not work in the first equation, right? So this is not a solution to the system. Notice that you don't even have to check the second equation because it has to work in both. You can check the second equation just, for kicks. Okay, so you can plug it in both and get -3 plus 4, which is 1. So the first equation checks out, or the second equation checks out, but it needs to be true in both for it to be a solution to the system. So the answer to that one is no. All right, any questions? Okay, let's look at number 3. Okay, so I just asked you to solve. I didn't specify solve with graphing or substitution or elimination, so it's up to you. I would not recommend graphing because, as I said, it's kind of really hard to read where they intersect unless you're really precise. And sometimes even if you're precise, if your answers are fractions, then it's almost impossible to get them exactly right. Okay, so from these we can do like elimination or substitution. Okay, so either one is fine. Okay, so let me do this one by substitution just to kind of practice the method. So if I look at my equation, let me label them first equation, second equation. The second equation looks like it's easy to solve for y. I'm going to subtract 2x from both sides. I'm going to get y equals -2x plus 13. Okay. And now you solve for y in the second equation, then you're going to plug it into the other equation. So when you see the y here, the parentheses gets plugged in there. Okay. So let's write that. First equation becomes 6x minus 5. Then y gets replaced by the parentheses, -2x plus 3. And I want that to be -1. Okay? So we have 6x, distribute the -5, plus 10x minus 15 is -1. Combine, so we have 16x minus 15 is -1. Oh, did I make a mistake somewhere? Oh, this is a 13, isn't it? Oops. Okay. I was getting fractions, and I just told you that there were no fractions. I missed the one there. So yeah, that's -2x plus 13, right? So positive 10 minus 65. All right. Okay. Okay, so this is minus 65 here. It's better. So add 65 to both sides. And we're going to get 16x equals 64. Divide by 16. X equals 4. All right. We're not done, but I'm going to pause just to see if there's any questions. Okay, so any questions so far on that part? Okay, so now we need the y. We need the y, so we go back to the beginning there and plug it in. So we have y equals -2 times 4 plus 13. Y is going to be -8 plus 13. Y equals +5. Okay, so the solution to this system is x is 4, y is 5. Okay, so that's the final answer there. All right. Okay, anyone have any questions with that one? All right, so substitution. Okay, so kind of in order of preference for the different methods, I like graphing the least, although graphing is useful in some cases. Then substitution is kind of, I could do it, but it's a lot of steps. And the last one, I like elimination the best because I think that one that's the quickest one. Okay, so I'm going to do the other two by elimination. Okay, so number 4. So I look at these two equations and let's do by elimination. So if I look at my y, I notice that this is a 3 and this is a 15. Okay, so if I want to eliminate the y, I'm going to multiply the first equation by -5. Okay, and the reason is that when I multiply the 3 by a -5, it's going to make it -15, and which is opposite of the +15, and that will cross out. Okay, so that's what you're looking for. It's going to focus on which variable do I want to eliminate, and what can I multiply the equation so they will be opposite numbers. Okay, so multiply the first by -5. So I get -20x minus 15y equals -10. Okay, and then the second equation is unchanged, 20x and 15y equals +10. Okay, and now this is where it might get confusing because you look at this as like, well, these cross out and these cross out and these cross out, so there's nothing left. Okay, but this doesn't mean that x is 0 and y is 0. It means that you have 0 left on this side and 0 left on this side. So there's no variables left. They're gone. Okay, they got simplified, eliminated. Okay, so you can't actually find what they are. You can't find numbers for them. What this means is that you get something that's true, but you can't find x is something, y is something. But when you end up with something like this, when it's true, this is infinite solutions. So x could be anything, and y has to be is stuck on that line. Okay, so y has to be the equation of the line if you solved for y. Okay, so it's infinite in the sense that it's any number, any coordinate points that's stuck on that line. So you just say infinite solution, and that's a good answer. All right, any questions with that one? Okay, so let's look at number 5. I think I need to get rid of the notations. Okay, so let me erase, let me clear the drawings and go to number 5. Okay, so number 5, I'll do it by elimination again. Okay, so again, I want to eliminate y. Okay, so I see that in the first equation I have -y, in the second equation I have +2y. So I'm going to multiply by 2 because that's going to give me -2y on top, +2y on the bottom, so they're going to cancel. Right, so let's multiply everything by 2. So negative 6x minus 2y is 16. 6x plus 2y is negative 16. Cross, 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 cross. Again, I end up with 0 equals 0. And that means infinite. Right. I meant to pick one that had no solutions, but that's okay. All right, this the no solution one is sort of identical, except at the end here, you're going to get something that doesn't make sense, like 0 equals 5 or something. But this is also infinite solutions. All right, any questions on the quiz? You doing okay? All right. Okay, so let me share Canvas. Okay, so let me go to Canvas and share screen. There's the Canvas website. Here we go. All right, so before I move on to the next section, okay, let me remind you of what we're working on. All right, so the assignments that are due as we're working through these sections are going to be completed on Canvas. You're still going to have a little bit of paper stuff that you're going to turn in, like the quiz, and we might have, when we come back from spring break, we'll do some activities that you probably have to sort of do on paper and then take pictures and upload it to Canvas. It's, again, we don't really have any idea of when we're coming back to campus or if we are. So kind of plan to do the class like this for maybe the rest of the semester. Again, I'm not sure if this is set in stone or not. But our next test, we're going to do like this. We're going to do it how you did your quiz. So you're going to get problems. You're going to do it on paper at home. You're going to take pictures and you're going to upload it in Canvas. So that's going to be the method. Okay. So the assignments that you're doing for this chapter, you should be completing the video lessons. Okay, so where it says the video lessons, anything that has points associated to it, you should do, because it's an assignment, it's a graded assignment. Again, the video lesson for graphing, you should have worked on by today, right? So I made the deadlines for these to be by the end of class today. So, so if you had any questions, then we can I can answer them. So complete the video lessons. These are only like a few minutes long, and there's a couple of problems associated with them. And then 5.1 homework solved by graphing, and the video lessons by substitution, by elimination, and then 5.2 homework was solving systems of equations. Okay, so these were sort of the assignments that I asked you to buy today. All right, so let me go over section 5.1 because I got a couple of emails. It's like how it's not giving me full credit. What do I do? Okay, so let me look at some of those graphing problems here. Okay, so these are sort of the kinds of problems that sort of you have to graph the lines. Okay, oh, this is a good one. Okay, because it sort of it's impossible to graph the y-intercept. Okay, so we can sort of look at this. So I have y equals negative x minus 6. Now, if I graph this the usual method, the easy one, I would say, oh, the y-intercept is negative 6, but it's off the grid, so it won't let me do it, okay? So we actually need to figure this out with the table of values. See, that's why it's good to know more than one method, because you can do it when you're sort of stuck in a situation like this. All right, so let's pick some values for x. Well, if I pick x is 0, then that's going to be -6, and this is a bit useless because it's off the scale. So I'm going to pick x is -1. Actually, if I pick +1, then I get -7, and that's also useless, okay? Because it's even lower off the scale. So I'm going to pick -1, then I get negative of -1 minus 6. +1 minus 6 is -5. Okay, so that's a good point, right? And then I'm going to pick -2. So negative of -2 minus 6, +2 minus 6 gives me -4. Okay, so those are two good points, okay? So now to graph it, you're going to make sure this button is pressed, okay? And then we're going to put a point at -1 and -5, which is here. That's a point on the graph. And then I'm going to put a point at -2 and -4, which is here. Okay, so that draws the line. All right, cool. Now let's look at the second line. The second line, y is -2x minus 8. Again, can't really do with the intercept because -8 is way down here and I can't see it. So I'm going to make a table of values again. So x and y. Okay, so I think let's do -2. So x is -2 because it gives me -2 and -2 minus 8. 4 minus 8 is -4. Okay. It's good because it's on the grid. And then I'm going to pick -3. So -2, -3 minus 8. 6 minus 8 is -2. So kind of the reason I'm picking negative x values is that I want to get sort of play around. I want to get y values that are on the grid that is shown here. Okay. So those are good points. All right. So let's, again, this line is selected. And I'm going to plot a point at x is -2, y is -4, which is here. Okay. And -3, -2. So -3, -2 is here. And then this other one is there. Okay, so the lines are drawn. All right, so you've graphed the two equations, but to indicate the solution, to tell the computer that you know where the solution is, it wants you to put a dot at the intersection. Okay, so after you graph the two lines, you want to click on this button with the one big dot in it and take the pencil and draw a dot where the lines intersect. Okay, if you don't do that part, then it only gives you partial credit. All right, so you put that on there, you click submit, and then you get the green check. That means that you did everything correctly. All right, any questions with doing these in Canvas?
You said it was 5.2 homework also?
Yes, so 5.1 homework and 5.2 homework. So 5.1 is this with the graphing, and 5.2 is doing by substitution and elimination. Okay, those are the ones that are due today. All right, any other questions? All right, okay. All right, so today we're going to look at 5.3. So let me just show in Canvas what we're working on. All right, so we're looking at, so yeah, today we're going to look at 5.3, which is like solving systems with special solutions and kind of just more practice with solving systems of equations. So we've already done a couple of examples of special solutions. We're sort of, those are the no system with no solutions and infinite solutions. So we're basically just going to do just a few more examples of the methods that we've learned so far. And we're skipping 5.4. We're going to look at some application problems. Okay, so we're going to look in particular for like mixture problems and money problems. So 5.3 and 5.5 today. All right. Okay, so let's look at what the 5.3 homework looks like. So again, we're using just the methods that we've learned to solve some systems. And I'm just going to go over some of these problems on here. I think it kind of randomly generates, so you guys get different problems that I do. So I'm going to work through some examples of these types. Okay. All right, so give me a second. I'm going to write that problem down on a sheet of paper and then share that. So we're going to solve the system y plus 2x is 2 and negative 1y is 2x minus 2. Okay, just a sec. Okay, actually, I'm just going to try to work it on here. I think that might be better just where the problem is. Trying to organize myself on this laptop. Okay, so this is solve by graphing. Enter the solutions in the boxes below. If the lines are parallel, enter D and E does not exist in each box. If the lines are coincidence, so they're on top of each other, enter 0, 0 in each box, infinity. Okay. All right, so let's look at these two equations. So the first equation, I'm going to solve for y. So we have y plus 2x equals 2. So subtract 2x from both sides. We get y equals negative 2x plus 2. Okay, so it's asking me to do it by graphing. So let me make a graph here. Okay. I'm going to draw 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right. So we have y-intercept at 2, and the slope is negative 2 over 1. So down 2 over 1. I'm going to draw the line. Okay. Now, second equation. So the second equation says negative 1y is 2x minus 2. Divide everything by negative 1. We get y equals negative 2x plus 2. Okay, so notice that it's the same equation. Okay, so again, y-intercept is positive 2, and the slope is negative 2 over 1, and it's going to be right on top. Okay, so these are the kinds where this is infinite solutions. Okay, so that's what I call like a special type of system is these ones that you get. Not just like the crossing, but they're on top of each other, they're parallel to each other. Okay, so how they directions to enter it says that if they're coincident, if they're in infinite number of solutions, then enter infinity on each box. So it says to enter that you put 2 zeros. So 0, 0, so it looks like infinity. 0, 0, looks like infinity. All right, and then you're going to submit. Oh, sorry. It says enter the letter O, not 0. Oh. That looks more like infinity. They're right. Okay, there you go. Oh, perfect. Check. All right. Any questions with this? Okay. All right, let's look at another problem. Okay, let's solve this one. I'm not going to do it by graphing because it's not my favorite way, and I don't like graphing with like the stylus. It's very crooked. So this might be good by elimination. Okay, let's see what we could eliminate. Okay, so I see I have my x's and my y's. Let's eliminate y. Okay, so to eliminate y, this is a 3 and this is a 2, so I need to multiply both. Okay, I'm going to multiply the top one by 2, and that will make this 6. I'll multiply the bottom by -3 to make that -6. So we want opposite numbers, same value but different sign. All right, so let's do that. That 2 has to multiply everything. I'm going to get -6x plus 6y equals -12. Positive 12x minus 6y equals positive 6. Right? Then we're going to add in columns. So -6 plus 12 is 6x. These cross out like we wanted. And -12 and 6 is -6. Right? Cool. And we divide both sides by 6. And we get x equals -1. Right, so that's my x value that will go there. All right. Now we also need to find the y value. So right now, once you find this, go back to either one of the equation. Doesn't matter where you plug it in. So I'm going to choose to plug it in the number 1. So I have -3 times -1 plus 3y equals -6. 3 and 3y is -6. Subtract 3. 3y equals -9. Divide by 3. So y equals -3. Okay. All right, so got my two values. Let's check them. -1 for x, -3 for y. Submit. Okay, that looks good. All right, any questions on this? All right. Okay, let me work through one more problem. Let me just look at the problems here. Okay, yeah, let me look at one more problem here. All right, so solve the system by graphing again. Okay, so I have y plus 5x equals 23. So subtract 5x. So by graphing, I want to solve for y. -5x plus 23. That's a big number. Wow. All right, so let's draw this. Ooh, look at that. They have straight lines. This is so much better than I was doing. Oh my goodness. Look at this. Straight lines. All right, so let's do by 5. 5, 10, 15, 20. 5, 10, 15, 20. So I want to do by 5s because my y-intercept is so big. 5, 10, 15, 20. 5, 10, 15, 20. Okay. All right, so My y-intercept is 23. So I'm going to put a dot where I'm kind of guessing 23 is. And the slope is -5/1. So go down 5 units. So each tick mark is 5 units. So go down 5 units and then over 1. Okay, this is not going to be very good. How about I go down another 5 units, another 1. Okay, the next is 0, 1. All right, so it's going to look like this. I think this will be a very bad approximation. All right, let's see. The next equation 2 right here, it's already solved for y, right? And so the y-intercept is 24, which is above 23. But notice that the slope is the same, okay? So slope is the same, that means they're parallel. Right, and this intercept is 23, that intercept is 24, so they're gonna start at different points. That blue line is going to be next to it, not on top of it, is going to be next to it. So they're parallel to each other, okay? That means they're not going to cross. So this means no solution. Right. I'm glad I didn't have to guess the crossing point for that one. All right, so when there's no solution, it says enter DNE in each box. So DNE does not exist. And we're going to click submit. And that's the correct answer. All right. So again, so the graphs, the slopes are parallel, but the y-intercept are different. So they're going to kind of go with the angles and never cross each other. So the solution does not exist. Okay, any questions with that one? All right, let's take our break. It's 10:55. So stretch your legs and get something to drink, whatever you need, and be back in 10 minutes. Again, during break time, you feel free to ask me questions if you have questions about anything that's happened so far or what's going to happen in the future, although I can't predict it. So yeah, go ahead and take your break now. Be back at 11:05. All right. Let's continue the class. Okay, so we're going to look at, I'm going to share my screen. Let's see. So we're going to look at some application problems now. So systems of equations are actually lend themselves really well to some kinds of application problems where math is useful. So we're going to, there's like lots of different kinds of problems with systems of equation, but I'm going to concentrate on what I call like money problems and mixture problems. Okay, so those are the ones we're going to look at. I don't want to sort of do too many because it just kind of gets a bit confusing, right? So let's look, this is like a typical problem. I grabbed this from our book. Right, and this is, again, if you're referencing the book, this is from section 5.5. Going to work through some problems in that section. So those are some application problems. I didn't want to cover 5.4 because, again, sort of other application problems, but just too many formulas, too many things. So just sort of slimming it down a bit. All right. So says tickets for a show are $70 for the adults and $50 for children. One evening performance had a total of 300 tickets sold, and the receipts totaled $17,200. How many adults and how many child tickets were sold? All right. So this is like a typical kind of money and mixture problem. You sort of, because they're basically two different kinds of things. All right. So let's look at what our variables are. Okay. So I usually like the last sentence right here. It's a good place to look to figure out what exactly am I trying to find and define your variable. So it says how many adult and how many child tickets were there. So these are my variables. So let's say A is how many adult tickets. Okay. And C is how many child tickets. So we have two different types of tickets, and they're going to cost different amounts. And we're interested in how many of each were sold. Okay. All right. Now, because we have two unknowns, we need two equations in order to solve this. So we need to find equation one somehow from our sentences, and we need to find an equation two. All right. So the first equation, look at sort of the how many tickets. Okay, so when we kind of have money problems, okay, so this is a money problem. Right? Who doesn't have money problems, right? So how many? Okay, so the first equation I usually write is like how many of each type of things, right? And the second equation is how much money. So one equation will count from the amount of sort of physical things, tickets in this case, you have, and the second equation will come from how much money you have. All right, so let's see. So tickets for a show are $70 for adults and $50 for children. Okay, so this kind of gives me information that I'm going to put here. So each adult tickets, so $50 each for adults, and no, $70 each for adults, and $50 each for children. But that's not what I need to know. I need to know how many tickets in total. Okay. It says one evening performance had a total of 300 tickets sold, right? So that tells me how many actual tickets were sold. Okay, so this gives us the equation A plus C equals 300. Okay, so yeah, imagine that you have a pile of tickets. There's like the little ticket stubs, right? And kind of it's like you're counting. It's like how many tickets went to the adults and how many tickets went to the children. But in total, there were 300 tickets sold. So you can say that if you put the pile of adult tickets and a pile of child tickets together, then it's going to count to the 300. Okay, so this is by what I mean by how many. It's an equation that has to do with the number of physical items that you're selling. Okay. All right, now the equation has to do with money. Okay, so I see that it says that the receipts totaled $17,200. So that basically means that that's how much money the show, the theater company, took from the people. So again, some of it came from the adult tickets, some of them came from child tickets, but in total, it was $17,200. Okay, so now I need to put the money in. All right, so this is going to come in handy. So I know that each adult ticket is $70. So if I write $70 times A, this is like $70 for each adult. That gives me the total amount of money taken from the adults. Okay. And then $50 for each child. If I write $50 times C, that gives me how much money I got from each child. Okay. 50 from each child. And so this gives me how many dollars from all the children together. Okay. So here's two equations. So this gives me a system of equation. So first equation comes from how many tickets. So if I put the adults and the children together, I get the 300 tickets. And then the second equation, you put the money in. Okay, so the 70 for each adult times the adults, 50 for each child times the child, and that will add up to this amount of money. Okay, all right. So this part right here is probably the most challenging part, translating what the problem says from words to the equations. So that's the part that we're going to practice the most. We're also going to solve it, of course, but now we need to solve. So we have two equations here. All right. So we have these two equations with two unknowns, and we can solve it by substitution, by elimination. I wouldn't recommend graphing because, as I said, it's a bit big numbers. We can graph it. We'll do some activities where we graph. But we can do this, let's do it by substitution, okay? So we're going to subtract A from both sides here. I'm going to say C is 300 minus A, right? And this part is going to be substituted into the second equation for C. So again, you erase the C and you replace it by the parentheses. So I get 70A and then 50, 300 minus A equals 17,200. Okay, right, now I distribute. 70A plus 15,000 minus 50A is 17,200. Okay, now we combine these. 20A plus 15,000 is 17,200. Subtract 15,000. Okay, and we get 20A equals 2,200. I think I'm 15,200. Yes, okay. Divide by 20. We get A equals 110, I think. Let me just grab my calculator. There we go. 2,200 divided by 20, 110. 110. All right, so I got a number. All right, so if I kind of look back at what I was looking for, it's like A means how many adult tickets. So that means there were 110 adults that went to that play, to that show. Yeah. Okay, but I'm not done, right? I'm not done until I find the other answer. Okay, so I have the adult. I go back to the beginning to figure out the child tickets. I go back to this equation right here. And I'm going to say C equals 300 minus 110. And that's going to be 190. Okay, so that's my full solution. So this says that 110 tickets were for adults and 190 tickets were for children. All right. Any questions so far? Okay. So let me show you how to check. I won't check every single time, but it's really good. Whenever I do these problems, I've been doing these problems for years and years and years. I still check. I check in my head or I check with a calculator to sort of plug the numbers in. But to check, you want to plug in the equations, right? So if I plug in my first equation, I should get that if I do 110 for adults and 190 for children, that should give me 300. Okay, and it does. All right. And then I'm going to check the money equation. So I'm going to check this equation right here. So that says 70 and 110 plus 50 and 190. So if I plug that in my calculator, so 70 times 110 and then plus 50 times 190, that gives me in my calculator 17,200. Okay, and that checks that out. All right, so these are easy to check. So you might as well do it just to kind of convince yourself that you got the right answer. All right, any questions with this problem? Okay, so this is like a typical mixture problem with money. So let me find one. Okay, I'll find another one and put it up. Okay, so tickets for a dance recital cost $15 for adults, $7 for children. The dance company sold 253 tickets and the total receipts were 2,771. All right, so you might want to kind of try it out, sort of try it on your piece of paper and um, kind of follow me a little bit as I'm doing it, but you want to try to do this a bit more independently. So how many adult tickets, how many child tickets? So again, I'm looking for A and C. So this is how many adult and how many kids, how many children. Okay, so let's look at our equations. Okay, so first equation, again, we're looking like how many things do I have? Tickets in this case, okay? So it says that the dance company sold 253 tickets. So again, we're now looking at the money part. The money part will come in this equation. So the money we're going to put in here. The tickets we're going to put in here. Okay. So I have the number of adults, the number of children is going to be 253 in total. So that's my first equation that comes from just the number of people or the number of tickets. All right, now the second equation, I'm going to put the money in. Okay, so I have money for adults, money for children, and money in total. Okay, so the 15 gets attached to the adults, and the 7 gets attached to the children, and the total goes on the side. All right, so here's my first equation, second equation. Okay, any questions on the equation part? All right, okay, so let's solve. So first equation, I'm going to solve for C. So subtract A from both sides, and I get that C equals 253 minus A. Okay, and this gets plugged into here. So 15A plus 7, 253 minus A equals 2771. Okay, we go through the steps to solve it. So distribute the 7. So 15A plus, go to that my calculator, 7 times 253, 1771 minus 7A is 2771. Combine these, 8A minus 7 plus 1771 is 2771. Subtract this from both sides. We get 8A equals 1,000. Divide by 8. So A is going to be 1,000 divided by 8, which is 125. All right. Okay, so I found the adult tickets. How many adult tickets? Okay, then we go up to here. Use a different color so you can kind of see it's a separate step. Ooh, pink. All right, so we're going to say C equals 253 minus 125. 253 minus 125. I get C equals 128. There we go. All right, so this is my answer. 125 adult tickets, 128 child tickets. All right, and again, you can check. You can check. I usually just do it in a calculator. So I go to equation 1 and say 125 plus 128 is 253. Absolutely. And then I go to the second equation and do 15 times 125 plus 7 times 128 gives me 2771. So that checks out too. Okay. So you should check at the end just to make sure that you got your numbers correct. All right, any questions with that one? All right. Okay, let's look at another problem. So we grab one. Okay, here's one. All right. There you go. Here's another money kind of problem. Okay, so this has to do with coins, quarters and dimes and the value. Okay, so it's similar to the other one, but a little bit different. So it says Random has a cup of quarters and dimes with a total value of $3.80. The number of quarters is 4 less than twice the number of dimes. There's a typo here. I should say dimes. All right, how many quarters and how many dimes does Brandon have? All right, so let's look at our unknowns and look at our equations, okay? So how many quarters? So let's say Q is how many quarters? And D is how many dimes? Okay, now we're going to find our equations. So again, the first equation, we're going to say like how many, and the second equation is the money, the dollar amount. Okay, that's kind of a good way to organize. Right, so how many? So that's, so ignore anything that has a dollar amount. So it says the number of quarters is 4 less than twice the number of dimes. Okay, so it says the number of quarters, 4 less means I subtract 4s, 4 less than twice the number of dimes. Okay, so that's that expression. So the number of quarters is, which means the equal, 4 less than twice the number of times. So Q is 2D minus 4. All right, so a little bit different because we didn't have the total. We just sort of told the relationship between the dimes and the quarters. All right, now we're going to put the money in. Okay, so it says that it has a total value of $3.80. Okay, so I have my quarters and I have my dimes. And if I add the value of them, then I get $3.80. Okay, so this one, sort of, we have to be a little careful because we're not just saying that Q plus D is 380. This is not correct because Q stands for how many coins you have that are quarters, and D stands for how many coins you have that are dimes. So let's say you had 10 quarters, you have to figure out how much money that is, okay? So we need to kind of put in how much money it's worth. So each quarter is 25 cents. All right, so each quarter is $0.25. Okay, so this goes here, 0.25, because we're looking for the value of the quarters. And each dime is 10 cents, okay, which is $0.010. So I put 0.10 in front of the D, okay? So that makes it dollar amounts rather than how many coins I have, right? Okay, so here's the first equation that has to do with how many coins, and the second equation has to do with how much money. So everything has to have money in it. All right, so now we can solve it. Okay, so again, we'll do it by substitution. So the first equation is already solved for Q. I can take this part here and put it in there. Okay, so let me do it up here. I have 0.25 times the Q gets replaced by this parentheses. Right, and then 0.10D equals 3.80. Okay, so now distribute. So 0.25 times 2 is 0.50D minus 1. 0.25 times 4 is just 1.00. And then 0.10D equals 3.80. All right, I'm going to combine the D's. So 0.5, 0.1, 0.60D minus 1.00 is 3.80. Add 1 to both sides. We get 0.60D equals 4.80. Divide by 0.60. And we get D equals 8. Let me just check. I'm pretty sure. 4.8 divided by 0.6, 8. Okay, so that means there are 8 dimes in the cup. All right, any questions so far? All right, so I still need to find the quarters. So I gotta go up here. And I'm gonna say Q is 2 times 8 minus 4. So Q is gonna be 16 minus 4, which is 12. Okay, so I have 12 quarters and 8 dimes. All right, let's check. Let's check to see if this makes sense. Okay. Yes, again, if I look in the first equation, the number of quarters needs to be 2 times the number of dimes minus 4. So 16 minus 4 is 12. That checks out. Sort of the one where you kind of really know if whether you got it right or not is when you put the money in. Okay. So if I have 12 quarters, then that's going to be $3, right? 12 quarters gives me $3. All right, and if I have 8 dimes, that's going to be 80 cents. And if I add these together, that's going to be $3.80, right? So it checks out what the problem said. Okay, any questions with this problem? Okay, so you guys can chat, ask me questions. I can sort of go over stuff again. You can speak up over your microphone. All right. Okay. Let's see. Going to bring another problem over. So give me a second. Okay. I'm just doing a new sheet of paper so I can do more problems. There we go. Okay, I'm going to copy a problem from the book over here. There you go. Okay, so how many pounds of nuts selling for $6 per pound and raisins selling for $3 per pound should Kirk combine to obtain 120 pounds of trail mix that cost him $5 per pound? Okay, so this is similar to the problems. So the first three problems we had tickets, adults and children. The second problem we had different coins. Here we're having like different food products, nuts and raisins. Okay. So let me start kind of doing some sketches for the problem. It really helps. Oh, you don't see that problem. Excellent. Thank you for letting me know. I think I need to share. So let me share here. There we go. Okay, now that shows. All right. So I'm gonna start kind of making some sketches because it really helps organize all the information. Okay, so here's a tub of nuts, and here's a bag of nuts, and here's a bag of raisins. I'm thinking of, you go to Sprouts, they have those barrels and they're full of things that you can put in bags, right? So you have the barrel of nuts and you have the barrel of raisins. So you're picking a certain amount from each. and you're putting it in your bag and you're making a mixture. You're going to make a trail mix, all right? So the question is telling you that you don't know how much you're going to pick of each. So you're going to have X from nuts and Y from raisins. But I know you know that the total that you want a total of 120 pounds. All right? So the amounts for each are unknown, but you know that the total is 120. All right. But they also give you information about how much it costs. So the nuts is $6 per pound per LB. And raisins are $3 per pound. Right? And you want the mix to be $5 per pound. Right. So this is a good way to organize. You have like your different kinds of things in sort of different boxes or different barrels. And you want like information about the amounts and information about the money. Okay, so this will help us find the two equations. So let's look at the blue equation. So the blue equation has to do with how much, what's the amount, okay? So I see that X plus Y equals 120. So pounds of nuts, pounds of raisins equals pounds in total, right? So that's the first equation there. Second equation, you have to put the money in, okay? So because it's like $6 per pound for nuts is going to be 6 times X. And $3 per pound of raisins is going to be 3 times Y. Do this again. Times Y. All right, and it's because it's $5 per pound for the mix is going to be 5 times 120. Okay, so notice I'm multiplying because it's so this dollar amount is for each pound because this times the X, that times the Y, 5 times the total amount. So everything gets multiplied by the dollar amount. So whatever was like in the first equation gets multiplied by its individual dollar amount. Okay, so now we solve this. Okay, so we're going to go through the solution. Okay, so first equation, we're going to subtract X. We're going to get Y equals 120 minus X. And then put this in parentheses and go plug it into here. All right? So we have 6X plus 3, 120 minus X equals 5 times 120, which is 600. Okay, distribute. 6X plus 360 minus 3X equals 600. Combine the x's. 3X plus 360 is 600. Subtract the 360. Just a second. There we go. Cancel out. 3x equals 240. Divide by 3. So x equals 80 pounds. Okay, so that means I found how many pounds of nuts I have. I need 80 pounds of nuts for the mix. All right, now we go to here and plug it in. We get y equals 120 minus 80. And we get y equals 40. So 40 pounds of the raisins. Okay, so 80 pounds of nuts, 40 pounds of raisins will give you the right mixture that will cost $5 per pound. Any questions with that one? Okay, so these are referred to as mixture problems. Okay, so let me find a couple of other problems. We're going to do sort of similar problems of these with solutions and with interest rates, with money. Okay, so here's one. The typical like mixture problem that has to do with mixing solutions. Okay, so Joy is preparing 15 liter of a 25% saline solution. So here's basically you have a bottle or a beaker, right? And we have another beaker, and we're going to mix them together to get some sort of mixture. Okay. So she's preparing 15 liters of a 25% saline solution. So she only has 40% and 10% solutions in her lab. How many liters of the 40% solution and how many liters of the 10% solution should she mix to make the 25% solution? Okay, so let's start labeling things. All right, so this is the stuff that she has. She has 40% solution and 10% solution. And she wants to mix these together to make something that's 25% solution. Okay, so a solution means that you have something plus water. There's something mixed with water. And a saline solution means that you have salt mixed in water. Okay, so that's what a saline solution is. Now a 40% saline solution means that in this mixture, 40% of the mixture is salt and the other 60% is water. And 10% means it's 10% salt and 90% water. So those are what those percentages mean, okay? So we have the different types of solutions. So I guess she has those already pre-mixed in the lab, but she needs to mix them up to figure out to get something that's 25%. Right? So she wants to know how much of the 40% and how much of the 10%. So she doesn't know that will make 15 liters of the mixture that she wants, right? So here's sort of, these are my variables here. Okay, so these will help us figure out the equations, okay? So I can see like the first equation is for the amounts, how much? So how much of each? X of the first, Y of the second is gonna give me 15 mixture, right? Now the second equation will have to do with these percentages. This is like the money that we had before, okay? Now with percentages, you always want to change them to decimals, okay, by dividing by 100. Okay, so 40% means 40 divided by 100, which is 0.40. And 10%, 10 divided by 100, 0.10. And 25% is 0.25. So divide by 100 in your calculator to change it to decimal form. Okay, so you want to use it in decimal form. So we have 0.40 times the x and 0.10 times the y is 0.25 times the 15. Okay, so it's pretty much like the same, the nuts and the raisins problem, except instead of per pound, you have this percentage, okay? But it works the same. Okay, so those are my two equations. All right, so now we're gonna solve them. All right. So the first equation, we're gonna subtract x from both sides. We get y equals 15 minus x. Okay, and that gets plugged into here. So 0.40x, 0.10 times 15 minus x equals 0.25 times 15. 0.25 times 15, 3.75. Okay, distribute 0.40x 1.5 minus 0.10x equals 3.75. Okay, combine the x's. 0.40 minus 0.10, 0.30x plus 1.5 equals 3.75. And minus 1.5 from both sides. 0.30x equals 2.25. And then divide by 0.30. And we get x equals, my calculator, 7.5. Okay. All right, so that means 7.5 liters of this first solution. Okay, so we need to backtrack, go up here and figure out what y is. So y is going to be 15 minus 7.5. We subtract and we get 7.5. So this is also 7.5 liters. So an equal amount of each will give you the desired concentration for your saline solution. Okay. So yeah, these are kind of good problems. You can see mixture things if you're sort of mixing any chemicals, or if you kind of have like oil that you need to mix in with gasoline for different things, or if you sort of mixing hair product stuff, and it's just like this is or medicines to get the right concentration for a certain patient. So these are very applicable ones. All right, any questions on this one? Okay, so I'm gonna grab interest problem. Okay. Get rid of this and like that. Okay, so this is very similar to the others. Okay, so let's look at green. Okay, so after 4 years in college, Josie owes $65,800 in student loans. That's why you go to community college, so you don't get that debt. All right. The interest rate on the federal loans is 4.5%, and the rate on the private bank loans is 2%. The total interest she owed for 1 year was $2,878.50. What is the amount of each loan? Okay, so very similar to the others. Okay, so basically you kind of think of these as buckets of money that you give to the bank that you took away from the bank. All right, so let's see. Okay, so this one represents like the first loan, the government loan. So let's say government loan. And this represents the private bank loan. Private bank loan. See, I use green for money. Right. And this represents the total. So this is the total debt, total loan. Okay, so same as before, we're asked to figure out how much in each. So how much can she borrow from the government and how much should she borrow from the private loan? But in total, she needs $65,800 to pay for her college. All right, so those are the amounts. Now let's look at the interest. Okay, so each of these loans, the banks charge her interest. So for the first one, the government is 4.5% interest. And you got to change this to a decimal. So divide this by 100. So the decimal point gets moved 2 places. So you get 0.045. So be careful with these. Often people miss this extra zero. Okay. For the private bank loan is 2%. Divide this by 100 and it's 0.02 like this. All right. Now for the total, it doesn't give you a percentage. It gives you a interest amount. Okay. So here is going to be $2,878.50. Okay. So this is a little bit different than the others, that it's sort of that percentage was already multiplied in here to give you this amount right there. Okay. So this has already sort of been multiplied. All right, so let's look at the equations now. All right, so let's look at the first equation. We have the x plus y equals $65,800. Right? And the second equation is going to be just as before, the percentage multiplied by the x. But we need it in decimal form. So 0.045 times x, and then 0.02 times y. And here we write the smaller amount, the interest amount, $2,878.50. Okay. Again, the other problems here, it's like we are multiplying the percentage by the amount. In the previous problems, we were multiplying the amount per pound times how much was for the mix. But this one, with the interest rates, that multiplication has already been done for us, and we're sort of given this interest amount, which goes here. Okay. As a rule of thumb, for the interest problems, the bigger dollar amount goes with the x plus y, and the smaller dollar amount goes with the sort of the interest part. Okay. All right. So now we're going to solve. So we're going to do by substitution again. So subtract x from both sides. And we get y equals 65,800 minus x. And we take this and plug it into here. So 0.045x and 0.02 times 65,800 minus x equals 2,878.50. There we go. Distribute. 0.045x plus, my calculator for this one, 0.02 times 65,800. I get 1316 minus 0.02x is 2878.50. Right. So this part, 0.045 minus 0.02, 0.025x plus 1316 is 2878.50. These just have a lot of numbers in them. It's funny reciting all the numbers. All right, let's go up here. 0.025x equals 2878.5 minus 1316, 1562.5. Divide. cross out. So that divided by 0.025 gives me $62,500. All right, cool. So that's my value of X. All right, let me just check. 0.0265,800 minus 2878.5 divided by 0.025. Okay, that looks good. All right, I'm not done until I plug in. So I gotta figure out the Y value is gonna be 65,800 minus 62,500. $65,800 minus 62,500 gives me Y is $3,300. Okay, so that's the answer for our problem. So the government loan was 62,500 and the private bank loan was 3,300. All right, okay, any questions with this problem? All right, so those are the types of problems that you're going to see in your homework. So let me go share the Canvas shell. If I can find it. All right, let's see. Let's do it again. Share. Just a sec. Okay, there we go. Okay, so okay, so what we've done today, chapter 5, there we go. We looked at solving systems with special solutions. So you should go over these video examples and the 5.3 homework. So solve system of equations, similar to what we're doing before, just sort of more a review and problems with things that have no solution and infinite solutions. All right, so you can watch them like video lessons for mixture problem, money problems. All these are graded assignments. And then you have like 2 homeworks for 5.5. One's called money problems, one is called mixture problems, okay? All right, so these are what the problems look like. Okay, so you can see there's a investment one, which we've just done, okay? And here's another investment, more investments. I seem to really like those investment problems. Okay, this is like an amusement park for child and adult tickets. Nickel and dime problem. Another one, another one. Okay, and concert for adult and child tickets. All right, same kind of problem here. And another interest problem. And this is another interest problem. Okay, so those are the kind of problems that we've been going over. So instead of, I'm recording this session and I'm gonna upload it to YouTube. It takes me a couple of hours. They're big files, so it takes like forever to download them. All right, and this homework here with the mixture problem, I think this one is shorter. So this is like the solutions, 20% of this, alcohol solutions, more alcohol solutions. So these are all kinds of problems that I've done over the lecture. So you can kind of go back to the lecture and kind of see the steps. And also the video solutions, the video lectures that I'm asking you to do for homework really helps. All right, so it's 5 minutes left in class, but I'm gonna end here. And please, I made the deadlines for these assignments for the chapter 5.3 and 5.5 video and homework due Sunday night. So you should please do those by Sunday night. And let me know if you're having any problems. You can email me and I'll respond. I'll make like little short videos. If you're having troubles, I can make little short videos and send them to you. And have a really nice break. So we'll be back on the Tuesday after the break. And over the break, I'm going to catch up on grading. I know I have a couple of quizzes and Barbie Bungee to grade for you. And I'll do that over the break. Okay? So you guys have a really great time and keep healthy, okay? Let me know if you have questions as you're going. I'll be here for the next hour in office hours if you need to talk to me.
Hi, Professor. I noticed that for the I think the second example we did today that you multiplied the two equations by a different number. So for the first equation was negative 3x plus 3y equals negative 6x, and you multiplied it by 2.
All right, I'm afraid it's really garbled. I can't hear you very well.
Oh, I'm sorry.
Okay.
You
yes,
think maybe I should put it in chat?
No, it's better now. I think you just need to maybe be close to your computer or to your phone.
Okay.
Okay, yeah, I can hear you now.
So anyways, for the second example, you multiplied each of the equations by a different number. And so the first equation was negative 3x times 3y equals negative 6, and you multiplied that one by 2.
Yeah.
And the second equation was negative 4x plus 2y equals negative 2. And you multiplied that equation by 3. I was just wondering where exactly you got those numbers, and so why you multiplied them by those numbers.
Okay, so read the two original equations for me again.
Okay, negative 3x plus 3y equals negative 6. And the second one was negative 4x plus 2y equals negative 2.
All right. Okay, so let me share my screen and then we can look at those. Okay, so share my desktop. All right, go. Okay, so that's the problem as you read it to me.
Yeah.
Right.
And you multiplied the first equation by +2.
Yeah. Okay, so I took it and I multiplied this by +2.
And you multiplied the second one by -3.
Okay, yes.
I was just wondering where exactly you got those numbers and
Yeah.
no.
So I'm looking, so when I have my original equation, I looked at my y, okay?
Yeah.
So I said, I want to eliminate the y variable, okay? So
Okay.
this has a 3 and this has a 2.
Yeah.
So those numbers, I flipped them around. I said, let's take this 2 and go here, multiply that by 2. And this 3, I'm going to multiply the second equation. But I made a negative because I want to end up with opposite signs.
Okay.
Okay? So yeah, that's where those come from. All right? So
Okay.
notice what happens now when you multiply, you get -6x and 6y equals -12. And then I get 12x minus 6y equals 6. All right, so this is what I want to end up with. I want to end up same number but opposites, right? Plus 6y and minus 6y because I want them to cross out. I want them to cancel when I go to the next step.
Okay.
Does that make sense?
Yeah.
All right, so yeah, because now they're going to cross out and I don't have any more y's. I just have 6x is -6 and I can figure out what x is.
Okay.
Yeah, but yeah, at the beginning, it's like you decide what do I want to eliminate, and then you can multiply by, if this is a 3, then you multiply this by 3, and if that's a 2, you multiply that by 2. So you kind of go opposites. But then sometimes you want to change the sign too, to make one positive, one negative, so that they end up opposite signs from each other.
Oh, okay.
Excellent.
All right, thank you.
Sure. All right, so Denise, are you still here? Let me see. Oh, cool. All right, so let me put up some quiz problems and you can take the quiz if you like. Let's see if I can find a place to write them. Actually, here it is. All right, I'm going to share the screen and you can do the quiz problems. Okay, there they are. So go ahead and do the solutions on a piece of paper and then take a picture and upload it in Canvas. Let me know when you're done if you need me to show you how to do it, okay? All right, and Francis, I'm going to check your test now. If you're around and hear me, I'm going to check to see if it's submitted correctly.
Hey, thank you, Professor. Can you hear me?
Hmm? Yeah? Yeah?
All right, so Francis, I checked your test. It looks, you can see the signature. All the problems look clear. I can grade them. Perfect. Okay.
Oh, Professor. Oh.
Hi, Jane. How can I help you?
So when I was trying to submit my test, I had a problem
Okay.
and my phone camera is not working. So So when I was submitting, it didn't like submit or anything.
Okay.
So what should I do in this case?
Do you have another camera that you can use?
Yeah, I do.
All right. So are you able to take pictures and maybe email them to yourself?
Yeah.
Okay, let's do that, and I can open up the test for you again, and you can submit them.
Okay.
Okay.
Okay. So I go to assignments and it's under test number 2.
Yeah, but it's probably closed right now, but I'm gonna extend the deadline for you so you can upload the files.
Okay. Thank